microcontroller, it has two timers which can act as counters also. And these timers and counters, they are of 16 bits. Means a 16-bit number can be loaded into these timers and the counters. Now these timers or counters, they can act as time delay generators also and as counters also. So let us study about these timers and counters in detail. So 8051 microcontroller, it is having two counters and timers. Means these two can act as counter also and as timer also. So when it is acting as timer, it is used to generate a time delay. And when it is acting as a counter, it is used to count the events which are happening outside the microcontroller. So this timers or counter, they perform two operations, either to generate the time delay or to count the number of events. Now because it is having two counters and timers, so these two timers are timer 0 and timer 1, and they can be used either as the timer or the counter. Now these timers, they are 16 bits wide. Means timer 0 is also having 16 bits and timer 1 is also having 16 bits. Okay. So because each timer is having 16 bits, so it is also divided into 8 bits. So 16 bits, they are also divided into 8 bits. 8 bits high byte and 8 bits for the low byte. So higher byte, it is denoted as TH and lower byte, it is denoted as TL. Okay, so 16 bits, if we want to have a 16-bit number, then we can use the whole timer, and if we want only 8 bits to be used, then we can use the higher or the lower byte timers. The 8051 counters, means when these timers and counters, they are acting as counters, counting the number of events. So they always count up. Means we are going to initialize them with a value of 0, and we are going to load the count value that from 0 to its maximum value, it is going to increment the counter. Always count up means that the counter is going to increment. Okay. So these counters, because they are 16 bits counters, so each counter can load a value of 16 bits. Okay, and each counter is having a special register, a count register in the special function register area. In 8051, we have some space reserved for the special function registers. These registers are 8-bit registers and they have special functions associated with it. So for each counter, that is counter 0 and counter 1, or we can say timer 0 and timer 1, we have a count register in this SFR area. And in that count register, the count value can be loaded. Okay, so here the timers are of 16-bit, so 16-bit value can be loaded. So if we talk about that the counters always count up, so we will have the initialized value as 000. It can count maximum up to F. Means when all the 16 bits are 0 to the condition when all the 16 bits are 1. So when we load this count value into this count register, this will be incremented, like it will become 0001, then 0002 up till the value of FFFF. So that is the maximum count value that can be counted by each of the counters of 8051. Okay. Now when this counter is incremented, when it is initialized with 00 and it is incrementing and it reaches to the maximum value, and again it is incremented. So again it is going to come back to 0000. Okay, and that condition is called the overflow condition. Means the counter has reached to its maximum value, again it is incremented, and that condition is called the overflow condition. So in that condition, for each counter we have an overflow flag bit, and that will be set in that condition. For timer 1 also we have a overflow flag, and for timer 0 also we have an overflow flag bit. So for corresponding timers, those flag bits will be set whenever the count value is overflowed. Okay. So this condition, whenever the counter is overflowing, that is called count rolls over. So whenever their count rolls over from the maximum count, that is FFFF, again to 0000, means this condition rolls over condition, the corresponding timer flag in the TCON register, it is set. TCON is the timer control register. It is an 8-bit register. We will study about it in later. That this TCON register, it is having the flag bits for both the timers. So that flag is going to be set whenever this overflow condition is achieved. So this was the little introduction about the two timers of the 8051 microcontroller. As I have said that these timers, they are 16-bit timers. So for timer 0, we will have 16 bits which are divided into two 8 bits, that is TH0 and TL0. That is for timer 0, the higher bits, and for timer 0, the lower bits. Now if this is the 16-bit register, so out of these 16 bits, we have the 8 bits for the higher and 8 bits for the lower. So this is TH0 and this is TL0, and complete is the timer 0. So we can load an 8-bit count value also, and we can load a total 16-bit count also. So separately they can also be accessed as two 8-bit registers, and collectively also we can access it as a 16-bit register. Similarly for timer 0, timer 1, it is also 16-bit, and it can act as two 8-bit register, that is TH1 and TL1. Timer 1 higher bytes and timer 1 lower bytes. So this is from D15 to D8 and this is from D0 to D7. Okay. Now let's come to the two registers which are associated with the functions of these timers and counters. We have the two registers T-mod and T-con. These are two special function registers, means registers which are having a special function associated with it. So these two registers are for the timers operation. This is for timer mode. Timer mode register, and this is for timer control register. Okay, and these two are the special function registers. Both these registers are 88-bit registers, 8 bits for T-mod and 8 bits for T-con. So this register, it is going to decide that in which mode the timers is going to operate, and this timer control registers, it indicates the status of the timers, that whether the overflow condition is achieved or not, or the control bit is set or not. That will be given by this T-con register. Let us study the format of these registers in detail. So this timer mode register, it is an 8-bit register. 8 bits are specified here. Out of these 8 bits, the lower 4 bits are for the timer 0 and the upper 4 bits are for timer 1. Now each of these 4 bits, they have specific function. Like this D7 and D3 bits, it is for the gate. This gate bit means starting and stopping of the timers. If we want that 8051 it counts, if we want to use its counters, so first we have to start the counters. Okay, so this gate bit, it is used to start or stop the counters. If we want to start, then we will set this bit as 1, and if we want to stop the counter, then we will set this bit as 0. So this bit is used for starting and stopping of the these counters. Now this starting and stopping of the counters, it can be done by hardware means also and by software means also. Hardware means we can give an interrupt to it. Either we can give an interrupt or we can reset the microcontroller. So if we are resetting the timers or counters, they will be stopped. And software means is that we can write the instructions. We can set this bit 1 or 0. So to start and stop, we have software means also. Software methods are also there and hardware methods are also there. Next bit we have in these two sections is the counter and the timer bit. This bit is used to decide that whether the two timers, they will operate as a counter or as a timer. So this bit is going to decide that the timer will generate a delay or it will count the number of events. So if this bit, if it is 1, then it will act as a counter, and if it is 0, then it will act as a timer. Means it will generate the delay. Next bit in this TMOD register we have is M1 and M0. These two bits in both the timers, it is used to decide the modes of operation of timers. These two bits, they can take different combinations like 0, 0, 0, 1, 1, 0 and 1, 1. So depending upon the combination, we have the 4 modes: mode 0, mode 1, mode 2 and mode 3. Okay, so let us study in detail what are the 4 modes of operation of these timers. So when these two bits, they are having the value 0, 0, then mode 0 is there, which is also known as the 13-bit timer mode. When it is 0, 1, then mode 1 is there, which is called the 16-bit timer mode. When it is 1, 0, then we have mode 2, which is called the 8-bit auto reload. And when we have mode 3, it is called the split timer mode. Okay, let us study that how the timers function in these modes. First, we will study the mode 1, which is the 16-bit timer mode. So this mode is known as the 16-bit timer mode. So 16-bit count value will be loaded into the count register. Now this 16-bit count value, it can take the values from 000 to FF, FF. Okay, so this count value can be loaded. Okay, and we have the registers there, that is timer 1 and timer 0 is there. So we have TL and TH, that is lower and higher bytes. So these bytes will be loaded into these two 8-bit registers. Okay, now if we want that the timer starts counting, then we have to start the counters. Okay, and these counters can be started by using the instructions set B TR0 and set B TR1. This is for timer 0 and this is to start the timer 1. So first step in whenever we want to start the counting operation is to start the timers. Count value is loaded. Now counters are started by using these two instructions. After that, the counter starts counting up. Suppose it is loaded with the value 0, 0, 0, 0. It is incremented 0, 0, 0, 1. Again it is incremented 0, 0, 0, 2 till it reaches its final count value, which is F, 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 F. Okay. Now when this maximum count value is reached, again it is incremented and it is come back to its again its initial value, that is 0, 0, 0, 0, and that condition is called the rollover condition, which we studied earlier. Now when this rollover condition is achieved, I said that the overflow flag bit is set. So for timer 0, we have the flag bit which is called TF0, overflow flag bit, and we have TF1 for timer 1. So whichever timer is overflowed, that flag bit is set. Means it is made equal to 1. Okay, and the programmer, it can see this flag bit. If it finds that this flag bit is set, so it is going to stop the timer. It is going to clear this set condition, because we have set these bits as 1. So it is going to reset it. It is going to stop the timers. So that stopping can be done by the two instructions, CLR TR0 and CLR TR1. This is to set the timers, start the timers, and this is to stop the timers. This is for timer 0 and this is for timer 1. So if we talk about this mode 1, the first step will be to load the 16-bit count value into the two 8-bit registers. After that, we have to start the timers. The timer will start counting up. Okay, when it reaches its final value, again it is incremented and it rolls back to its initial value. So when this condition is achieved, when overflow has occurred, the overflow flag bits for the two timers, it will be set. And if we want to reset the timers, if we want to stop the timers, or if we want to reset them, then we have to clear the two bits, that is for timer 0 and for the timer 1. Okay. Now, if we want to repeat this process, that if we want that again the counter, it starts counting from 0000, means avoiding this overflow condition, again we have to reload the 16-bit count into the two registers, and again we have to start the count timers. Okay, so this was the mode 1, which is the 16-bit timer mode. Now let's come to the mode 0. The difference between mode 1 and mode 0 is that mode 1 was 16-bit timer mode and mode 0 is 13-bit timer mode. Otherwise, all the operations are same. First, the timers are started, count is loaded. In 16-bit count, the maximum value was FFFF. But here we are having 13-bit, so its range will be reduced 0000 to 1FFF. So this is the maximum count value allowed in mode 0. This is loaded into the TH and TL registers. Counter is started. When overflow is achieved, overflow flag bit is set. Then timers are stopped by clearing the bits. Next is mode 2. Mode 2 is known as the 8-bit auto reload mode. 8-bit mode means here we cannot load the 16-bit count. We are going to use the timers as separate TH and TL timers. Okay, 8-bit timers are there. This 8-bit count is loaded into the higher bytes of the timers, and a copy of this is placed in the TL register also. So suppose we have loaded it with because it is an 8-bit number, so 002FF can be loaded. Okay, maximum count value allowed is FF. So suppose we have initialized here, means we have loaded the count value 00 in TH. So that will be copied into the TL register also. Now this TL is going to be incremented. It will be incremented till it reaches the maximum count value FF. When it is FF, again it is incremented and the rollover condition is there, means again it is 00. So when this rollover condition is achieved, again the flag bits, they are set for timer 1 and timer 0, that is TF0 and TF1. In this case also we have to first start the timers by setting the bits. Okay, and when this overflow condition is set, these two bits are set. Now if we want that if we clear it, means this rollover condition is there, if we want to start that this process is again repeated, the programmer need not to reload the count here, okay, because this th bit, it is again automatically copied into the TL. Count is first loaded in th and it remains there, it will not be modified. So again and again the programmer need not to reload the count value, okay. It is going to just every time the timer, it is going to copy this count value from into the TL will be incremented, okay. That is why this mode 2 is called the auto reload mode. But in mode 0 and mode 1, every time the count value is overflowed, the programmer has to reload the count value, okay. Next mode is the mode 3. In mode 0, 1 and 2, the operations of the timer 0 and timer 1, they are independent of each other. If suppose timer 0 is operating in mode 0, the timer 1 is operating in mode 2. So their functioning is completely different. They are independent of each other. But in mode 3, the two timers, they are not independent of each other. They will collectively work. Suppose that we have initialized the timer 1 in mode 3. So due to this, the bits TR1 and TF1, that is the timer control bit and the timer overflow bits of the timer 1, they will be used by timer 0. So it means that the functioning of the two timers, it is means it's a combination of it. They are cooperating with each other, means not independent, okay, we can say. So timer 1 bits, they are used by timer 0 if it is initialized in mode 3. So that is why it is called split timer mode. The functioning of the timers is mixed up. So these are the 4 modes of operation of the timers. Next, this was the T-mode register, which is used to decide the modes of operation of the timers. Next, special function registers associated with the timers is the T-con register. It is the timer control. Now, this register is also an 8-bit register. So it will have the 8 bits from D7 to D0, and each of the bit will have some function associated with it. So let's see the format of this T-con register also. So these are the 8 bits of the T-con register. D7 bit, it is for the TF1, that is timer 1 overflow flag. Okay, this condition is means this bit is set. Set means its value is made 1 whenever the count value, means counter, is incremented from 0000 to 1111. So when this condition is achieved, the maximum count value is achieved, then this bit is set, okay, otherwise it is reset. So this is for timer 1 and this TF0, it is for timer 0. Then we have TR1 and TR0. This is for timer 1 and this is for timer 0. So these bits are timer, run, control bit. Okay. So these bits are for the starting up of these timers. If we want to start the timer 1, then we are going to set this bit. If we want to start timer 0, then we are going to set this bit. Using the instruction what we studied, set B TR0 and set B TR1. Okay. Then we have IE1 and IE0. These are for to enable the external interrupts. These are for the interrupts. Okay. IE1 and IE0. So it is to enable the external interrupts. These are the edge. E is for the edge flag. Okay, so this is to enable the external interrupt edge flag 1 and this is to enable the external interrupt edge flag 0. So this is related with the interrupt structure. Also we have this IT1 and IT0. These are for the external interrupt signal type control bit. Okay, these are to decide that at which edge, means either from low to high transition of the clock pulse or from high to low transition the interrupt is going to work. So these bits are related for the interrupt operation. For timers only we have this TF1, TR1, TF0 and TR0 for timer 0 and the timer 1. So this was the TCON register, which is the special function register having 8 bits. So in this video, we studied about the timers, or we can say counters of the 8051 microcontroller. We studied that it has 2 timers and counters which can act as a delay generator also and as the counter also. Okay, and we studied the 2 special function registers associated with it, TCON and TMOD. So I hope that this topic is clear to you. Thank you.